While muscle paralysis is often associated with deep sleep, it specifically occurs during rapid eye movement, REM sleep, REM Atonia. In contrast, non-REM deep sleep, stage N3, is characterized by general muscle relaxation, tissue repair, and hormone release. The primary landmark study on the exact chemical mechanism behind sleep paralysis was published in the Journal of Neuroscience, 2012, by neuroscientists Patricia L. and John H. Peever at the University of Toronto. Key neurotransmitters causing muscle paralysis, REM Atonia. The University of Toronto study demonstrated that sleep paralysis is driven by two primary inhibitory neurotransmitters acting together on motor neurons, GABA, gamma aminobutyric acid, the brain's main inhibitory neurotransmitter, Glycine, an inhibitory amino acid neurotransmitter active in the spinal cord and brainstem. How the mechanism works: sublaterodorsal nucleus, sub-C, activation. During REM sleep, glutamatergic neurons in the brainstem activate inhibitory premotor neurons in the ventral medial medulla. Dual receptor blockade. These neurons flood skeletal motor neurons with GABA and glycine, targeting receptors. The chemicals bind simultaneously to both ionotropic GABA-A/glycine and metabotropic GABA-B receptors. Motoneuron hyperpolarization. This dual signal hyperpolarizes motor neurons, essentially switching off electrical signals to skeletal muscles. This causes complete atonia, paralysis, to keep you from physically acting out dreams. Withdrawal of excitatory signals. Simultaneously, excitatory neurotransmitters, norepinephrine, serotonin, and histamine, are shut off during REM sleep, removing any remaining drive to move postural muscles. What happens in deep sleep, stage N3? During true NREM deep sleep, the chemical profile shifts from paralysis to tissue recovery and muscle relaxation. Human growth hormone, HGH. Deep sleep triggers a surge of HGH release from the pituitary gland. This hormone stimulates protein synthesis, cellular repair, and muscle restoration. Muscle tone and stiffness. Muscles remain relaxed rather than paralyzed. However, intense physical repair, fluid shifts, and lactic acid processing during this stage can lead to a feeling of stiffness or tightness upon waking if muscles were overworked or inflamed prior to sleep.